Today we are going to discuss about the production of energy from carbohydrates. So what are carbohydrates? Carbohydrates are the compounds which are made up of carbon, hydrogen and oxygen. Also these are further divided into three categories, that is polysaccharides, oligosaccharides and monosaccharides. So what happens? The food we eat contains carbohydrate. For example, such as starch, lactose, maltose. There are a number of carbohydrates are there. So these carbohydrates are further broken down in our body. That is, these polysaccharides such as starch are broken down into dextrins. These are the monosaccharides, or you can say glucose, mannose, fructose. So there is further breakdown of carbohydrates into glucose in our body. And what happens? For example, we have taken this glucose. So what is the fate of glucose? Glucose goes into the cell with the help of hormone insulin, which is a common factor which is responsible in case of diabetes. So we are not discussing about it further. What is the fate of glucose? Glucose goes through the three cycles, you can say, for the production of energy. First one is glycolysis, second one is PDH complex, that is pyruvate dehydrogenase, and third one is Krebs cycle. So what happens in glycolysis process? There is conversion of glucose, which is a monosaccharide, into pyruvate. Two molecules of pyruvate are produced here. So the net gain of ATP, the ATP produced are 2. Also NADH, which is also you can say a common factor for the ATP. 2 molecules of NADH are produced. So the important thing here to note is that 1 NADH molecules equals to approximately 3 ATP molecules. So you can say that in glucose 2 NADH are produced. So what happens? 2 into 3 is equal. So 6 ATP are produced from 2 molecules of NADH here in glycolysis. So we can say that the net gain of ATP in glycolysis is 8 ATP if we conclude NADH also. So further what happens? As glucose is converted into pyruvate molecule, so there are 2 molecules of pyruvate are produced here. So these 2 molecules of pyruvate enters into the PDH complex, where pyruvate is converted into acetyl coenzyme A. The thing here to note is that as 2 molecules of pyruvate are there, so 2 acetyl coenzyme A will be produced. So what is the gain of ATP here? We are here to discuss about the gain of ATP. So in here PDH complex, 2 NADH molecules are produced. So what I have told here is that 1 NADH is equal to 3 ATP. So 2 into 3 is equal to 6. So here in PDH complex there is gain of ATP is equal to 6 ATP. Further, this acetyl coenzyme A, as you have studied also, enters into the Krebs cycle. So as 2 molecules of acetyl coenzyme A are there, so it will go 2 cycles, remember that. So in each cycle 1 ATP is produced, 3 NADH and 1 FADH is produced. FADH is similar to NADH, but the difference here is that flavin is there, that is 1 FADH is equal to 2 ATP molecules. So that's the basic difference here. So 3 NADH will result in the production of 9 ATP and 1 FADH will result in the production of 2 ATP. So in the second cycle, if we count the second cycle also, 9 into 2 is equal to 18 and 2 into 2 is equal to 4, as this cycle will happens 2 times. So the total ATP gain here in Krebs cycle is 24 ATP. So further, if we count the total gain of ATP in glycolysis, PDH and Krebs cycle, it will be 8 plus 6 plus 24, and that is equal to 38 ATP. So what we have got is that from one glucose molecule, what we have got is 38 ATP. So it is the currency of energy in our body, you can say. So this is our result, that is 38 ATP are produced from 1 mole, or you can say 1 molecule of glucose. So thank you so much for viewing this video. If you have liked my video, please subscribe it and press the bell icon also. Thank you so much.